Okay, so in this video, we'll be discussing part C of internal one paper, that is data preprocessing for complaint analysis, right? So these are the seven questions and we will one by one discuss about it, right? So first is discuss accuracy, completeness and consistency issues, missing timestamps, contradictory narrative, mistype section, propose two more quality dimension relevant to legal analytics. So let's see. First is accuracy issues. What can be accuracy issues? Accuracy refers to how correct the data value are. That means how correct our value is. It should not be wrong in the data set. It should mean to correct thing. Otherwise, it could lead to bad prediction or not good prediction, right? So examples is incorrect dates or timestamps, wrong monetary loss values, mistype legal section. For example, for IPC 420 section, we wrote IPC 240 section. There is major, massive difference between those two sections, right? So handling this values that should be meaningful, that should be related to the complaint is our concern, right? So what can be the impact? It could lead to incorrect severity scoring score, wrong section mapping, and unreliable code recommendation. This is very trivial. This is not so impacts include leads to incorrect severity scoring, the scoring on which on that basis we are considering the prediction, right? Wrong section mapping. For example, for theft case, there is a criminal. You understand criminal mapping. Impact is it can lead to incorrect severity scoring, which could lead to bad prediction, wrong section mapping, and unreliable code recommendation. Right? So let's see completeness issue. Completeness means there should be no missing value in important fields. Like for example, we have a complaint and there is no section mapping to it, so it is not. So it will be just. So it will not make any sense, right? So now let's see completeness. Completeness refers to missing values in important field. There should be no missing value in the data set. For example, there could be missing timestamp, missing accused detail, missing offense category, right? Their impact can be causes failure in feature extraction and weak machine learning prediction. If there are multiple missing values in the data set, our model could not predict well in real-time environment, right? Next is consistency issue. Consistency means absence of contradiction in records. That means if two records are saying different thing, that means the two records are inconsistent. This should not be in the dataset. For example, same case show different monetary laws, contradictory narratives in multiple FIR versions, same offense mapped to two different legal sections. This is very wrong, right? Impact is it creates a legal ambiguity and misclassification, right? So now let's see additional data quality dimension that we can add. For example, timeliness, we can update it on real time. Data must be updated promptly. And because delayed FIR uploads affect investigation speed, right? Then we have verifiability and provenance. Every record must be traceable to authentication source. For example, there is a complaint and it should be relevant. If it is irrelevant, we could check it from the source. There should be a legal authentication source. On basis of that, we are checking the validity of complaint, right? Important for courtroom evidence and audits. Yes, very correct. Now let's see second question. For handling missing value and extractor features, discuss approaches, ignore tuple, manual completion, constant fill. Yeah. So let's see different imputation methods. Wait a minute. Handling missing values and extract features. The first one is ignore tuples. Here we remove records with missing value. Whatever is wherever in whichever tuple there is missing value, we remove those tuples. Then we have manual completion. Here we fill it with the help of domain knowledge or with the help of fixed value. Here we can either fill the missing value with zero or we can fill unknown. For salary, we can for salary in a employee data set we can fill value unpaid. Then we have mean imputation, where we can fill the missing value with the mean of the dataset. It is done for numerical attributes. Then we have median imputation. It is more robust metric than mean imputation because it is for it is for skewed distribution and for data with outliers, right? So median imputation is a very good metric. Then we have mode imputation for categorical feature. For example, we have a categorical feature and we got mode as yes. So we will replace the value with the yes. Then we have class specific imputation. Fill by offense category. We can fill the offense category. And then we have model based imputation. That is to use a ML model. We can use a nearest neighbor classifier, nearest neighbor predictor or regressor to handle the missing value, right? So this is the imputation methods. Now let's see question 3. Smoothing extracted score. Use the evidence strength list from A2. Smooth using bin means with bin depth 3. Suggest ways to detect outliers. Discuss other smoothing methods. Bin medians, Lewis, moving average, robust estimators, right? Let's discuss smoothing method. So let's take a raw evidence score. This is our raw evidence score. Let's create a bins for this. So we will create different bins for this based on the similarity. First, we will sort the data as we know that data is already sorted, so we don't need to sort the data. Then we will create bins of size 3. We will create equal size bins. Now we will calculate mean of each bin. Here, mean of bin 1 is 12.33. Similarly for bin 2 and similarly for bin 3. Then we have smoothed data. Now we will replace those values with the smooth mean. So this will lead to a smoothed data. This is done for smoothing, right? Then we have outlier detection method. There are various outlier detection method. First is Z-score method, in which we check if the data point lies outside the normal distribution, it is an outlier. Then we could have a interquartile range. If data point is outside the interquartile range, it is an outlier, right? Then we have DB scan density clustering. This tells if data is an outlier. Isolation forest, scatter plot, anomaly detection. These are various methods from for which we can do outlier detection, right? Then we have other smoothing methods. Bin medians, it is more robust than mean because for skewed distribution, our bin could lead to either left side or right side. So medians are a more better metric than mean, right? Then we have local regression smoothing. We can do smoothing based on the regression. Moving averages, which is time series FI trends, and robust estimator, which ignore extreme noise. So this perform better where our model leads to overfitting, right? Now let's see the question. Explain normalization methods. Okay, so we have different normalization method. First one is min-max scaling. In this scaling, first we calculate the minimum value of dataset and maximum value of dataset. Now with for each value x, we do x minus x min upon x max minus x min. This leads to a scaled value which lies between the range 0 to 1. And the scaling is often done to dampen the effect of outliers. So it is uh, very necessary, right? Then we have Z-score normalization where we normalize with the help of Z-score or normal distribution. Here X is the value, mu is the mean, and this is variance. This centers data around zero. Then we have a uh, median score, that is median z-score. This is more robust for data with outliers. Here we replace with the mean with the median, right? It is more resistant to outlier, yes. Then we have decimal scaling where we could convert the larger outliers to a decimal value. This is also a good metric for data with outliers as it could dampen the effect of outlier and increase the predictability of model, right? Okay, then let's see question 6. Binning case severity scores are, we are given different severity score, partition into equal frequency bin, equal width bins, clustering based bins. Okay, So we are given different severity scores like this. Now first let's make a equal frequency bin. So we have taken frequency as 4 and we have created equal frequency bins. Now let's say take equal width bins. First we will calculate a range. Range is nothing but the lowest value, highest value and minus lowest value. So here is the range. Then we calculate the width as 70. So based on that width, we take bin 1, bin 2 and bin 3. This way we create equal width bins, right? Then we have clustering based bins, often known as k-means clustering. Here we cluster them based on similarity. Like let's say 5, 10, 11, 13 are most similar. So we group them in same cluster, right? So based on that, we created some clusters and we have low severity score, medium severity score, and high severity score. Now, if a query comes, like for example, 98 severity score, where it does lie? So it lies in the high severity score, right? So based on that, we can tell it. Then we have section mapping implication. We could from this base bins, we could tell whether a section is whether a complaint is cognizable, non-bailable, or compoundable. But we have to be very sure because wrong binning leads to wrong legal action, right? Then we let's say what is question 7? Feature selection for section mapping, summarize with a flowchart, the techniques for choosing. Okay, so we know that for in dimensionality reduction, we have feature selection as a method, which now let's see question 7. Feature selection for section mapping, summarize with a flowchart, the techniques for choosing attributes used by DSS, forward selection, backward elimination, and hybrid method. So in dimensionality reduction, using feature selection, we try to reduce the number of features or we try to select only a subset of features which are important for our model, right? So let's discuss some of its methods. First of its method is forward selection, in which we starts with no feature and when we do cross validation or when we do training, when we train the training data, we start with no features and we see that which feature is affecting more on our prediction. So we select that best performing feature in our feature set and then we repeat until accuracy stabilizes or until the prediction score uh, not change, right? Then we have backward elimination. In backward elimination, we start with all the features and remove the weakest feature or that feature which is less contributing to our model prediction. Then repeat until the optimal set remains. And at the last, we get the subset which is best for our model and which have the least number of features, right? Then we have feature selection, that is hybrid method, which combines both forward selection and backward elimination. When we combine both of this, it is best suited for legal DSS where risk of omission is high. It is best suited for our environment because we are not either dependent on forward selection, we are not either dependent on backward elimination. We are using benefits of both, right? So these are the solution and discussion for the section part C part for internal one. I hope you find it helpful. Thank you.